Let's go over the shell method. With finding volume the usual way, using the formula pi times the integral from a to b of f of x squared dx, slices of the graph are being taken perpendicular to the axis of rotation, like so. In certain cases, we can't solve for the variable in the terms that we need to find the volume with perpendicular slices, or the graph is just too nasty to try using the traditional method, like f of y is equal to y minus y squared. Enter the shell method. We can think of the shell method as finding the volume of a hollow cylinder in which layers are rotated about an axis, forming a shell. The basic formula for the shell method becomes 2 pi times the height times the average radius times the width, which is 2 pi times p sub y times h of y times delta y. With a horizontal axis of revolution, we can draw horizontal rectangles. P sub y is the radius, the distance from the axis of revolution to the rectangle. H of y is the height of the rectangle, or the value of the given function. Delta y is the width of each rectangle. With a vertical axis of revolution, we draw vertical rectangles and set it up essentially the same way. P sub x is the radius, the distance from the axis of revolution to the rectangle. H of x is the height of the rectangle, or the value of the given function, and delta x is the width of each rectangle. As the width of the rectangles becomes infinitely small, we can use integration to find the volume of revolution according to this formula. With a horizontal axis of revolution, it's 2 pi times the integral from c to d of p sub y times h of y d sub y. Though p sub y and h of y may be dependent on your axis of revolution if it's not the x or y axis, usually p sub y is the function and h of y is simply equal to y. The formula for vertical axis of rotation is 2 pi times the integral from a to b of p sub x times h of x d sub x. Usually, p sub x is your function and h of x is simply x. Let's go over an example problem. Example 1. Find the volume of the solid of revolution formed by revolving the region bounded by f of y is equal to y minus y squared, or x is equal to y minus y squared, and the y-axis about the x-axis. We can draw the graph here, and draw a horizontal rectangle. The height of the rectangle, p sub y, is equal to y minus y squared, the radius is equal to y, or h of y, and the bounds of the integral are from 0 to 1, and the width is dy. With all this information we have, we can plug it straight into the formula and integrate. First we factor in the y, so we have 2 pi times the integral from 0 to 1 of y squared minus y cubed dy. Integrate that and we get 2 pi times y cubed over 3 minus y to the 4th over 4 evaluated from 0 to 1. Evaluate that thing and we get 2 pi times 1/3 minus 1/4, which ends up being 2 pi times 1/12. That's the easier part, and so the whole thing ends up being pi over 6 units cubed. Remember, while the shell method may be extremely helpful in some cases, sometimes the disk method may be more applicable. It all depends on the formula you're given. Sometimes tests will ask for a specific way. Usually the formula then will be able to use. But now at least you know how to use the shell method.